class, welcome back to my YouTube channel, and for today, our lesson is the lesson 2, which is about the probability distribution of discrete random variable. So from our lesson 1, we already discussed the discrete random variables, so the two kinds of random variables, the discrete and continuous. So this time we are going to get the probability distribution. So first, let's have our objectives for today's lesson. The learner will be able to illustrate a probability distribution for a discrete random variable and its properties. So we are going to discuss that. But first, let us have the probability notation. So from our first lesson also we introduced the probability. So the notation, we have the P of E, or a function of E. So probability of E. E stands for an event. So the probability of an event is the chance or the possibility or the likelihood that an event or that event will occur or will happen. So the probability values are ranging from 0 up to 1. So the value of the probability will not exceed to 1 or will not be a negative value. How can we compute for that probability? The probability of that event, of an event, is equals to the number of times that E occurs or that event happened over or divided by the number of possible outcomes or the total number of possible outcomes. So the probability will the probability just represent a fraction. That is why it will just range, the value will just range from 0 to 1. So if the E or the event will certainly occur or it will surely happen, then the probability will be equals to 1, or the extremes, the probability of that event. And if the E or the event is impossible to occur, to happen, the probability is equals to 0. So the extremes for the lower extremes also. And now, since we know the probability notation and how can we get a simple probability of a certain event, let's move to the probability distribution of a discrete random variable. So again, from our first lesson, the lesson 1, we know na we already discussed the discrete random variable. What is the discrete random variable? This is a kind of random variable whose values are countable or countable infinite number or a distinct values. So again, it can be counted. So why we are just discussing probability of the discrete random variable. So the discrete random variable has an exact outcomes. So that is why it can be easily again, the discrete and continuous are really different. So the discrete can be easily counted, and the probability distribution are the probability distribution will be exact or can be easily quantified. So what is this probability distribution? It is a rule or a table that consists of possible values of a random variable and its corresponding values. So the probability distribution for discrete random variable, we can either for a discrete random variable, we can either create a table or use a formula for this for its probabilities. So those the corresponding value between the random variable value and the probabilities is called the probability distribution function. So this probability distribution function will just for the discrete random variable will just be the rule or the table for our probabilities and random variable values. So to further understand, let's have the example. But first, let us have the properties of the probability distribution to have before we have an example. So the probability distribution has two properties. So the first one, so the probability of each value for the random variable is between, so it will just range from 0 to 1. Again, the probability will not exceed to 1 or will not be below 0 or negative values. So it will be from 0 to 1. And the probabilities, the sum of all the probabilities for that random discrete variable or the probability distribution should be or is always equals to 1. So it is not a probability distribution if your sum of probabilities is not equal to 1. So let's have examples. First example, let's say we roll a die, two dice. So first die, we have here the table for the outcomes for our first die and the second die. So let x will be equals to the sum obtained from rolling two paired dice. So our random variable x will be the sum of the obtained value of these two dice. So we have these outcomes 1, 2, 3, 4, 5, 6 for the first die, and the second we have 1, 2, 3, 4, 5, 6. So we get the sum per column and row. So we have 2 for 1 and 1 and up to 6, and then 6 for the first die and then 6 for the second die, we have equals to 12. So those are the sum that will be our random variable x. So the x values, so the sum will range from 2 to 12. So we just have 2 from 12. So we will not be having, so for the first die, for one die, we start with 1. So in here we have 2 since we have 2 dice. So the least number for the first die and the second die is 1. So when we sum it up, get the sum, and then we have 2. So this table shows, the chart shows us the 36-point sample space. So as we can see, we have this 6, then times 6, so we have 36. So we have 1, 2, 3, 4, 5, and up to 36. So each value, each event has a probability which is equals to 1 over 36. Why 1 over 36? Because the sum of all the possible values, all possible values is equals to 36. And again, each, so we have each one occurrence or event. So 1 over 36. We already have the formulas to probability notation also. That is just the same. And our random variable values for the random variable x, or the sum obtained from rolling two dice, are 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 11. So we have 2 to 11. Now, let us get the probabilities in this example number 1. So we have again the random variable values from 2 to 12. And the probabilities for these possible values, this is x, sorry. So it can be computed as follows. So for the probability that the sum you get will be 2 is equals to number of times that the sum 2 occurs over the number of possible outcomes. So that will be equals to how many times that the sum 2 occurs. So we can see this in this chart, in this table, we have 2. 1 only for 2. So that is equals to 1 over the total number of possible outcomes is equals to 36. So we have the probability that the sum 2 will occur is equals to 1 over 36. Or number 2, let's say we get the probability that sum 3 will occur. So as we can see in this chart, we have 1, 2, which is sum of 3. So we have 2 over total possible outcomes 36. So our probability is equals to 2 over 36. So let us tabulate it in our table. So again in this example chart, we have this probability distribution. So we have x for our random variable, so our values are from 2 to 12. And the probability of 2, so how many times 2 occurs? That is 1. So 1 over 36. Again, we computed it earlier. Then 3, we have 1, 2. Then over 36, then the lowest term is equals to 1 over 18. We just divide the numerator and the both numerator and denominator by 2 over 2. So we have equals to 1 over 18. And for 4, sum 4, we have 1, 2, 3. So 3 times it occurs as the sum for rolling 2 dice. So we have 3 over 36. So we divide the numerator and denominator by 3. So we have 3 divided 3, that is 1. So we have 1 here. And then 36 divided 3, that is equals to 12. So our probability for 4, probability P of 4 is equals to 1 over 12. And for 5, we have how many times for 5? 1, 2, 3, 4. So we have 4 over 36, or the lowest term is equals to 1 over 9. For 6, we have 1, 2, 3, 4, 5. So we have 5 times that the 6 sum 6 occurs. So we have 5 over 36. For 7, we have 1, 2, 3, 4, 5, 6. So 6 over 36. That is equals to 1 over 6. For 8, it's the same with 6. We have 5 total occurrences. So we have 5 over 36. And then for 9, we have 4 over 36, which is also equals to 1 over 9, the lowest term. And then we have 3 over 36, that is equals to 1 over 12. And for 11, we have 2 over 36, that is equals to 1 over 18. And lastly, for 12, we have 1, so 1 over 36. So this is the probability distribution of the random variable x, wherein our x is the sum obtained from rolling 2 dice. So again, second example, let's have another problem. In here, we are dealing with cards. So a deck of cards. So a deck or a deck of playing cards has 52 cards. I think we are all familiar that the deck of cards, disregarding the joker, the 2 joker, has 52 cards. So when we add the jokers, we have 54, but we'll disregard it. So we have 52 cards. So this 52 cards consists of 4 suits. So the 4 suits are hearts, diamonds, clubs, and spades. So the hearts and diamonds are called the red cards. So those two. So again, we have 4 suits. So each suits has 13 cards. So we divide 52 to 4. So 52 divided 4, that is 13. So 13. And the hearts and diamonds are the red cards, and the clubs and spades are the black cards. So 13 plus 13, so we have 26 red cards and also for the black cards. So each suits, again, ayan, has 13 cards. So namely the 2, 4, 3, 4, 5, 6 hanggang up to 10. So we have 9 plus the jack, 10, queen, king, and then ace. So we have 13. And the jack, queen, and king are also known as the face cards. So those are the terms that we need to remember, the concepts that we need to remember when we are dealing with events or solving about deck of cards or playing cards. So they are known as face cards because there is a face drawn to that card. So it's simply as that. So let's have the problem here. In this example 2, suppose a card is drawn at a random from a pack of 52 playing cards. So find the probability of, so we are going to find the probability of A, which is the card drawn is an ace. B, card drawn is red cards. And C, card drawn is a face card. So let's solve this problem example. So first, let's have the letter A. So our the letter A is equals to card drawn, which is an ace. So we all know that the deck of cards consists of 4 suits. So each suits, heart, spades, diamonds, and clubs, has 1 ace. So we have 4 ace in total. So the probability that we can get an ace will be equals to 4, since that is the number of occurrence that the ace will happen. So we have 4 ace all over 52, which is the total or the number of possible outcomes. Or the lowest term of 4 over 52, we both divide or simply divide 4 over 52 by 4 over 4. So we have 1 over 13. So this is the probability that the ace card will be drawn in a deck of cards randomly. Second, for the letter B in our example, this is the solution. So the B card drawn is red. So we all know that the red cards are the hearts and diamonds, the 2 suits, hearts and diamonds. So each suit has 13 cards. So 13 for hearts and 13 for diamonds. So we have total 26. So for the probability that the red cards will be drawn is equals to 26. So that is the total the number of times that it will occur all over 52, which is the total number of the possible outcomes. Or the lowest term of 26 over 52 is simply 1 over 2 or 1/2. So simply means that we have a half of red cards for a deck of cards. So that is the probability that we can draw a red card, which is the B. And last, for this example number 2, we have to find the probability of C. So that is card drawn is face card. So we all know that face cards are 4 jacks. So we have 3, right? 3 classifications. So 4 jacks, 4 queens, 4 kings. So 4 plus 4 plus 4, that is 13. 4 plus 4 plus 4, that is 12. Sorry. I love. So we have the probability of face card, which is equals to 12 over 52, because 12 total number of face cards all over 52 total number of possible outcome, or the total number of cards. Or when we reduce it to lowest term, this is 3 over 30, the probability of these cards. And lastly, example number 3, we have this problem about deck of cards again. So a hand of 5 cards is drawn from a pack of playing cards. Let E be the event that the hand contains 5 aces. So from our second example, we have for letter A the probability of ace. So we have 4 over 52. So this time, the hand contains 5 cards. So what is the probability that you will have 5 aces? So the probability of this event is equals to 0. Why? Because the aces is just 4, so we don't have a fifth ace because we have only 4 suits. So that means this is impossible, or the probability is equals to 0. So that's it for our lesson 2, which is all about probability distribution of a discrete random variable and its properties.